Hello, our grade 9 mathematicians. Right, we have a topic under exponents, and this topic is third law of exponents. So we are going to look at third law of exponents. However, this third law is then extended to fourth law of exponents. Right. So before we solve the problems that we have here, we're going to use these problems as examples. Let us just go through what the third law is and what the fourth law is. Then thereafter, we will then simplify the three problems that we have as an example. Then the classwork, it's from exercise 5.4. It's page 49. The textbook is today. It's number 1, 5, 9, 13, and 17. Then the home activity or the homework is 3, 7, 11, 15, 19. That's the work. Now, then let us look at the third law. Third law. The third law of exponents. Right, what is this all about? When we are looking at the third law of exponents, it says here, if we are having, say, for example, if we have a as our base, which is raised to exponent m, right? That's a raised to exponent m. Then this number is then raised to exponent n, right? So we are having a number which is the base a. This base a is raised to, allow me to say, to 2 exponents. In other words, base a has 2 exponents. So it means a number has more than 1 exponent on it. Right. So in this case, whenever we are simplifying such a problem in general, we say we are multiplying the bracket n times. The whole bracket is to multiply n times, right? So in this case, it was found out that we can shorten the whole process by just multiplying the exponents. So this is only true if a base has got 2 exponents. So a has got, is raised to exponent m, and the whole number inside the bracket is raised to exponent n. So it means we have to multiply the exponents that are raising the same base. So the exponents are multiplied, which then means that we can simplify it to a to exponent m times what? N. This becomes our final what? Answer, right? Yeah, we are going to deal, or you are going to understand this when we deal with values. Maybe you can have a clear picture of what is happening. So in short, if we are having a base that has got more than 1 exponent, it means you just multiply the exponents of that base, right? So we have 2 exponents, then we have to multiply the exponents. All right. Now, this is the third law. Let us then look at the fourth law. The fourth law, allow me to say, it is an extension of the third law, right? Fourth law of exponents. It is an extension from third law. So in this case, it's like we have a number that's a times b This is our base. So we've got two bases that are multiplying each other, and these bases are raised to exponent m. Right? We've got two bases. These bases are raised to an exponent. So generally, what it means here is we can distribute the exponent to the two bases that are multiplying each other. So our bases, we have base A, base B. So A and B are multiplying each other. Both of them are raised to exponent m. So we can simplify this by removing brackets to say it's A, right, times B. I'm just expanding it before I distribute the exponent. So this is now equals to, then we distribute the exponent to both bases, which means it's going to be A to exponent m times what? B to exponent m. I distributed the exponent to the two numbers that are multiplying. So in this case, it is only true if the bases are multiplying each other and they've got exactly the same exponent. So which means this is finally equals to A exponent m, B exponent m. That's the final what answer there, right? Now, so this is the third law. Remember we said it is a base that has got more than one exponent, right? So we multiply the exponents, then we simplify. Fourth law, it says we are having two numbers. These two numbers are multiplying each other and they are raised to exactly the same what? Exponent. So we just distribute the exponent to the two numbers. Now, let us look at the specific examples that we have here. So we have number 2. Number 2, we are having, that's 3 to exponent 4. And this 3 to exponent 4 is raised to exponent 2. Right? Now, allow me to make use of second law first. Then adjacent to it, I'm going to make use of what? Third law, right? So this is 3 to exponent 4. Everything is raised to exponent 2. So according to the first law says we have to what? It's like we are looking at the number inside the bracket. So the bracket is raised to exponent 2, which means this is equals to, then we say it is 3 to exponent 4. This is the bracket. We multiply by the same bracket, right? We multiply by the same what? Bracket. Now, when we multiply the same bracket, remember the first law says what? Whenever you are multiplying numbers having a common base, what do we do to the exponent? You add, right? So it means this is now equals to, then we say is 3 to exponent 4 times 3 to exponent what? 4. So what is the base, right? We can see here that the base is identical. The base is what? 3. So we take the identical base, right? Then we add exponents, which means that our final answer becomes 3 to exponent 4 plus 4, which is exponent 8, right? Now, since it is exponent 8, this is in index form. This is in index form, right? Now, but our question says simplify. The question says simplify. This is the question. It says simplify. So it means we can further simplify our final answer, right? Here we used what? First law. By using what? First law. From here, go on to this one. That's the first law. Then we simplify, we get it in index what? Form, right? Now, this is 3 to exponent what? 8. Now, 3 to exponent 8, it simply means we are going to get what? If we use our calculator, it means that our value is going to be, let me then calculate the value using our calculator. What is 3 to exponent 8? 3 to exponent 8. So our 3 to exponent 8, sorry, so it's 3 to exponent 8. Then the answer becomes, that's 6,561, right? It's 6,561. This is our simplified answer. So what I did here is to make use of first law. Whenever we multiply common bases, we add exponents. That's what we did here by using first law. Then from there, we simplified to index form. We have 3 to exponent 8. And this 3 exponent 8 gives us 6,561, right? Now, adjacent to this calculation, I am now going to make use of what? I'm going to make use of third law. By using third law, we are looking at 3 to exponent 4, which is raised to exponent 2, right? Which is equals to. So according to third law, it says, if we have a number which has got more than one exponent, it means we have to multiply the two exponents that are on one base. So 3 is the base. There are two exponents. The exponent is 4 and the other exponent is 2. So it simply means, according to third law, it is equals to 3 to exponent 4. Then we multiply by 2. We are multiplying the exponent because there are two exponents raising the same base. So this is now equals to 3 to exponent 4 times 2, which is 8, right? Then we simplify this, it gives us 6,561. So you can see here that it's a shorter method to simplify exponents or numbers that are having more than one exponent, right? So I'm now going to continue using the third method for our number 10, for our question number 10. Simplifying 12 times x to the exponent 12 raised to exponent 3. Right. Now, so in this case, we are going to look at number 10. So according to number 10 is 12 x raised to exponent 12 to exponent 3. Now you can see here that the number which is having more than one exponent is the bracket, the number in the bracket, which is x. 12 is exponent 1. There is no any other exponent on 12, right? Right? So since it is outside the bracket, the 12 is not affected by cube. 12 is not affected by exponent 12 on x. So x is the number that has more than two exponents. So it means we are going to use the third law, right? So it's 12, then the bracket is going to be multiplied. This is the bracket, it's going to be multiplied 3 times. right? That's using first law, right? So instead of using the first law, we'll just say, since there are two exponents raising the same base, we multiply the exponents. So it's x to exponent 12 times exponent 3, which is going to be 12x to exponent 12 times 3, that's exponent 36. Then, since we don't know the value of x, it means we can leave our answer as 12x to exponent 36. That's our final answer. Then, number 18. Number 18. Number 18, we are having bracket 2xy squared. 2xy squared. Then it's raised to exponent 2. Let us deal with that one. 18. We have bracket 2xy squared. Now, what we are seeing there is we are seeing one bracket that is raised to exponent 2. The bracket is raised to exponent 2, right? And inside we have 2xy squared. So it means each number inside the bracket is raised to exponent 2. That is outside here. Each number inside is raised to exponent 2. So we distribute the outside exponent to each number that is inside the bracket, right? I'll be using arrows. Since they are multiplying each other, we have to distribute it like that, right? So we are going to say it's 2 to exponent what? 2 times x, this x is exponent what? 1. So it is going to be 2 here. Then times this y. Y is already what? Squared. So we multiply by the incoming what? Square, or the outermost square. Right? So this is what is happening. So we just distributed the outermost exponent to each number that is inside the bracket, which means it becomes what now? 2 squared is what? 4 times x squared. There's nothing for us to simplify. It will remain x squared times y. We are having exponent 2 times 2, which is exponent 4, which means our final answer is equals to what? It's 4x squared y to exponent 4. That's our final what? Answer, right? So this number 18 is an example of law number 4, whereby we are saying each number inside the bracket is raised to the exponent that is outside the brackets. That's what we have. So we just distribute the exponent to the numbers that are inside.